Significant figures. When we have our measurements, we've talked about the fact that with different instrumentation, we only know numbers out to a certain point. So significant figures allow us to look at numbers and to figure out basically kind of how good that number is. How many digits are actually significant? How well do we know this number? So when we looked at our first ruler, when we talked about measurement and uncertainty, that ruler had some limitations. It could only go out to 0.1 centimeters. So we measured our first thing to 4.2 centimeters. Now our second ruler was much better. We were able to get that out to 4.25 centimeters. So in our first number here, this 4.2, only 2 significant digits because I only have 2 numbers there. This one, we have an extra digit. We had 3 significant figures. Now these numbers were easy, okay? There's no zeros there. When we have zeros, things get a little bit fussier. So how do we assess significant figures? Non-zero numbers, those are significant, like our previous 2 examples. When I have zeros, now things get a little bit more complicated. If I have zeros between non-zero digits, those are significant. So for example, if I have the number 101, that 0 is between 2 non-zero digits. It's significant. Zeros as placeholders are significant. So the biggest example for this course is when we have a situation where we have a tiny number. Like here, I've got this 0.0068. Those initial zeros, those are just placeholders. All that's doing is letting me know where the position of the decimal place is. If I were to rewrite this number into scientific notation, I would get 6.8 times 10 to the negative third. Neither of those zeros show up. They're not significant. Now, when I'm looking at trailing zeros, that's where things get crazy. Right? So we have a rule that says zeros after last digit are significant for numbers less than 1, or if they occur after the decimal point for numbers greater than 1. So what does this look like? Okay, let's say I have the number 90. No decimal point at all. That 0 is not significant. This is 1 sig fig. Okay? Now, what happens if we know that number is significant? Let's say it is a situation where I have something like a graduated cylinder, where I only have marks every 10 mils. I know that I can read that graduated cylinder out to 1 milliliter. So I know I can capture that 1 milliliter. So let's say that bottom of the meniscus falls right on 90. If I just report my number as 90 with no decimal, what that means is I haven't read that out to 1 milliliter. I'm only estimating to every 10 mils, really. So if I want to capture that 1 milliliter and that final number is a 0, what do? I would write it like this: 90 with a decimal and nothing after that. That tells me that both of those digits are significant, that 0 does mean something and it is significant, and I know something about that 0. So I'd have 2 sig figs. Okay? Now let's say I'm reading something that's a little bit better. I can go out to 0.1, and again, it falls right on something. How would I write that? Well, I would write it 90.0 and make sure I capture that 0, and there I'd get my 3 sig figs. Okay? So let's try this. All right, so we're going to take a look at a few numbers, and then we're going to determine significant figures and write them in scientific notation. Okay, so our first number here, I have these 2 trailing zeros and I have no decimal point at all. They're not significant. Now, they do count for the magnitude of the number. So when we do our significant figure determination, I would have 1, 2, 3, 4, 5 significant figures. And then when I write it in scientific notation, I'm going to get 9.8622 times 10 to the 6th. Okay, so if I expanded it back out, those zeros would show back up again because they do count for the magnitude of the number. They're just not significant. Okay? All right, my next one, my 0 here comes after non-zero digits and after a decimal point. So it is significant. That number, that 0 means something this time. So I have 5 significant digits. 1, 2, 3, 4, 5. Rewrite it in scientific notation. That number will show, or that 0 will show up. We're going to get 8.3790 times 10 to the first. Okay, now my next number. I have a couple zeros here and a couple zeros there. The first couple zeros, well, they do come after a decimal point. They come before a non-zero digit, meaning that those are just placeholders telling me where the decimal point lies. That last digit, or that last 0, comes after non-zeros and after the decimal, so it's significant. So my significant digits are 1, 2, 3, 4, 5, 6. Okay, I have 6 significant figures. Rewrite in scientific notation, 9.26570 times 10 to the negative third. Okay, next up, 40. Do you see any decimal points? No, there's not any, which means that 0 isn't significant. So I have 1 significant figure, and I'm going to rewrite this as 4 times 10 to the first. Okay? Next up, 773.1000. Those zeros are after non-zero and the decimal. Therefore, they're significant. So I have 1, 2, 3, 4, 5, 6, 7 significant figures. And I'm going to get 7.731000 times 10 to the second. Okay, and then my very last one on here, I have 800 with a decimal point, thus saying that those 2 zeros are significant. So I have 1, 2, 3 significant figures. And I'm going to rewrite this as 8.00 times 10 to the second. Okay. All right, now, what happens if we have an exact number? So these are all measurements. They all have that degree of uncertainty to them. But what if I have, I don't know, a dozen students? Can I have a fraction of a student? No. Can I round off a student? No. I have exactly 12 students. So exact numbers have an unlimited number of significant figures. I can put as many zeros on the end of that as I please because it is exact. It's not going to change. If I have a lab and I have 24 students in my lab, I have 24 students. I don't have 23.7 students. I have exactly 24 students because each student is a whole individual. Okay? So this starts to come into play when we have to deal with calculations and things. Because if I have instrumentation where I have a certain number of significant figures from one item and a certain number from another item, or I have something where I have an exact number and then a measurement, how do I determine, after I do math, how many significant figures to report? Well, the rules are different depending on if we are looking at addition and subtraction or multiplication and division. Addition and subtraction is the first one we'll take a look at. In addition and subtraction, we are not looking at the total number of significant figures in each measurement. What we are looking at is the least number of decimal points. And so what we take into account here is, and again, we're just looking at addition and subtraction right now. Okay? All right, so what we like to do with addition and subtraction is we like to line up our decimal point, and then we can draw a line so we know where to cut off. And then when we look at whatever number is to the right of that line, that's what informs our rounding. Okay, so let's take a look at this right here. So this first one, I had this 4.8, 1 decimal point, minus 3.965, 3 decimal points. So 1 decimal point is less than 3. So we can only keep that 1 decimal point. When we look at this, I have 0.835 is my answer. So now I need to round. So to the right of the 8, I have a 3. So if you recall from any other classes you've ever taken with rounding rules, if the number to the right is 5 or above, we round up. If the number to the right is 4 and below, we keep the number. So the number to the right of the 8 is a 3. That's 4 and below, so we don't round up, and the number is 0.8. Okay, so let's take a look at a couple more examples here. Okay, so my line is going to get drawn right here. Okay, so when I do the math, I am going to get an 8, 4, a 2, and a 1, 124.867. Okay, so my least number of decimal points is 1, so I get to keep 1 decimal place. So when I look here, my number to the right of the 8 is the 6. 6 is 5 and above, so in this situation, we would round up on the 8. So I'm going to get 124.9 as my final answer. Okay, over here, it's going to get a little dicey because the little screen with my face in it is right where I'm going to write my answer, but we'll make the best of it. All right, we're going to get negative 8 let's see here. Oh, I put the line in the wrong spot. Let's fix that. Okay, it's not going to let me go back. So here, let me rewrite it real quick. My iPad's being a little fussy. We're going to get this 0.765 minus 3.449 minus 5.98. So we would draw a line here. This is actually better. I have a little bit more space. We're going to get negative 8.664. And so the number to the right of that 6 is a 4, so we keep the 6. So our answer is negative 8.66. Okay. I'm doing a new way of recording my lecture videos, and so I'm still learning the limitations of what it allows me to do and what it does not allow me to do within the confines of the program. So I think it's working better than what I was doing before, though. Okay. All right, now let's get rid of this. And we'll move on to what we were talking about with multiplication and division. Okay, so multiplication and division, we have some different rules. So again, we are now looking at multiplication and division. Multiplication and division, you don't have to line anything up. All you're doing is you're looking at total number of significant figures. And so whatever your fewest number of significant figures is, that's the number of significant figures in your answer. So this number right here, we have 4 sig figs. This number right here, we have 3 sig figs. Okay, so our final answer, so 3 is less than 4, therefore final answer is going to equal 3 sig figs. Okay, so I'm going to go, okay, these two are not significant, so I'm going to start my sig figs here. So I'm going to take 1, 2, 3 sig figs. I draw my line there. And so the 1 is to the right of that line. Therefore, I'm going to round to the 7. So my final answer is at 0.0237. Okay, and so what we're looking at is multiplication and division. You're just looking at whatever the least number of significant figures is. Addition and subtraction, you're looking at the least number of decimal places. Exact numbers aren't going to affect anything. And then rounding, you're going to look at to the right of the last number you can keep is the number 5 and above or 4 and below. Okay, so let's take a look at a few examples here. Okay, all right, so our first example is some addition. So when you add these numbers together, you're going to get 177.15. So when I look at this, addition and subtraction, we can only keep the least number of decimal places. So here I have 1 decimal place, 1 decimal place, 2 decimal places. So 1 is my least number of decimal places. So I draw my line there. Okay, 5, we round up. So I'm going to get 177.2. Okay. My next one is multiplication. So when I do the multiplication, I'm going to get 27.999. Okay. So this number is 6 significant figures. This number is 3 significant figures. So 3 is what I get to keep. So I'm going to put that there. Now, when I have this situation where I have a 9 and a 9, well, when you round up 9, it goes to 10. So 27.9 with the 9 next to that means we round up. And so what we get here is we get 28.0 is how we round that up. Okay. Now, if I have units, I need to keep my units. Centimeters times centimeters gives me centimeters squared. Okay, next up is some division. So when I do my division, I get 1.69. Okay, here I have 3 sig figs, 2 sig figs, which means I can keep 2 sig figs. Drop my line there. This is going to round to 1.7. Okay, my last one, I have 16.4 minus and plus, so it's addition subtraction. So we're going to get negative 65.21. All right, when I look at this, I have 1 decimal place, 2 decimal places, and no decimal places, which means for my final answer, I don't get any decimal places. So I'm going to cut off at the end of the decimal place. I have a 2 there, so this is going to round to negative 65. Okay. So these take some practice. They're not something that you're going to remember all of these rules just from watching one lecture video. So make sure that you are doing your practice problems with these because it definitely takes some practice and recognition to start getting used to all of these significant figure rules.